Imagine a world just below us, where thousands of shimmering disks, microchips, rush through dark, silent tunnels. Each one is precious, as fragile as spun glass. These silicon wafers do not crawl along highways or drift lazily in a plane's cargo bay. Instead, they fly at supersonic speeds inside vacuum tubes, hidden deep beneath Europe's cities and fields. Every second, a new shipment launches. The air is gone from these tubes, so nothing slows the pods down, not even friction. Inside, the chips rest quietly, cocooned in special pods, while outside, they're racing faster than a jet plane. The stakes could not be higher. One wrong jolt or 1 minute's delay could mean factories stop, devices fail, and the world's tech supply chain breaks. The drama is real. If even a single wafer cracks, an entire batch of smartphones or cars could be delayed. In this silent world, speed is everything, but so is safety. It's a ballet of physics and engineering happening where nobody can see. As Europe's industries demand more and better microchips, the pressure rises. The Eurotube network is their hidden artery, pulsing with the lifeblood of tomorrow's technology. In the past, microchips traveled the old-fashioned way, by cargo plane or truck. Back then, this was enough. But as chips shrank to the size of dust, every bump in the road became a threat. Today's microchips are only 2 nanometers thick, thousands of times thinner than a hair. They are stronger than you might think, but also incredibly delicate. Freight trucks shake, airplanes vibrate and go through huge temperature swings. These movements seem small, but for a tiny chip, they are like earthquakes and heat waves. Even the best packaging can't protect them from every jolt or drop. And while these journeys take days, factories are hungry for chips in hours, not weeks. Global demand has exploded. Factories across Europe need millions of chips a day for phones, cars, computers, and even refrigerators. If the chips are late or damaged, entire assembly lines go quiet. That silence is expensive, costing companies millions by the hour. So the old ways are too risky and too slow. The world needed a new, faster, safer highway for its most important cargo. And that's why the Eurotube was born, to outpace the old world and shield these delicate wonders from every danger above ground. Beneath the cities and countryside of Europe, a new kind of highway stretches for thousands of kilometers. This is the Eurotube, a vast network of vacuum tubes buried deep in the earth. It is dark, silent, and almost completely empty inside. The vacuum is what makes the Eurotube special. With no air, there is no resistance, no drag. Pods can zip along at incredible speeds, never slowing down. The tubes connect chip factories, tech hubs, and assembly plants in every major city. It is a private world, hidden but essential, moving the most fragile cargo with absolute precision. Each tube is lined with superconducting tracks for the maglev pods to float on. The route curves gently, avoiding sharp turns that could damage the precious cargo. At every junction, smart switches send pods racing toward their next destination, guided by computers that never sleep. This network has become Europe's secret weapon. Without it, the continent's high-tech industries would grind to a halt. No trucks, no planes, just silent, unstoppable speed below our feet. Now let's peek inside a maglev pod. The word maglev means magnetic levitation. This pod doesn't touch the track at all. Instead, it floats, balanced by powerful magnets. There is no friction, no grinding, no noise. With a gentle push from electromagnetic coils, the pod soars forward, gliding like a ghost at over Mach 1.2, faster than the speed of sound. Inside, the microchips are cushioned in shock-absorbing cradles. The pod's shell is strong but light, designed to handle changes in air pressure and tiny jolts. Every pod is also sealed tight, protecting the chips from dust, moisture, and anything that might sneak in. Energy is used only at the start, to push the pod into motion. After that, it glides almost for free through the vacuum. It can travel from Paris to Berlin in under an hour, crossing countries in the time it takes to watch a cartoon. This is the magic of maglev. No wheels, no rails, just pure, frictionless speed. For fragile microchips, it's the safest way to travel. Microchips are, incredibly sensitive. Even a tiny vibration can ruin a whole batch. That's why every maglev pod is wrapped in layers of smart sensors. These sensors feel for the smallest shakes, bumps, or tilts. If trouble is detected, the pod's magnets adjust in a split second, balancing the ride and canceling out any vibration. The magnetic field acts like an invisible cushion, holding the pod steady as it races through the tube. The pod never touches the sides. This means there are no sudden jolts, no scratches, and really, no chance for dust to get inside. Sensors also keep an eye on the temperature and humidity inside the pod. If anything changes, alarms go off and the system makes instant corrections. The goal is simple: keep every chip as safe and perfect as the moment it left the factory. Every second, millions of bits of data rush to the control center. There, AI monitors each pod, ready to step in if even the smallest danger appears. There's another danger for microchips on the move: heat. Even a little warmth can cause defects in super thin silicon. That's why every pod is fitted with a cryogenic jacket, a special shell that keeps everything icy cold. Inside the jacket, liquid nitrogen flows around the chips. Nitrogen is a super cold gas that turns into a liquid at -196 degrees Celsius. It carries away any heat and keeps the chips at the perfect temperature. This protects them from thermal shock, sudden changes that could crack or warp the wafers. Engineers use simple science to make it work. As the pod speeds through the tube, the cooling system hums quietly, always watching the temperature. Sensors send constant updates, and if things get too warm, extra nitrogen is pumped in right away. With this cryogenic shield, even the world's tiniest chips stay perfect, no matter how far they travel. With thousands of pods zipping under Europe every hour, chaos could break out. That's where AI comes in. The Eurotube's computer brain controls every pod, every route, and every stop. It tracks each shipment from start to finish, making sure they arrive right on time. If a pod goes off course, AI instantly reroutes it onto a new path. If there's a problem in one tube, it closes that section and sends pods on a detour. It can even slow down or speed up pods to avoid traffic jams or keep fragile loads apart. For special cargo, like experimental chips, AI gives them a clear track, making sure nothing slows them down. Every second, the system checks weather, power, and maintenance needs, always looking for trouble before it happens. Thanks to AI, the Silicon Highway never sleeps. It's always thinking, always protecting, always delivering. The Eurotube is only the beginning. Engineers dream of running these tubes under the sea to connect continents. Imagine chips made in France arriving in China or the United States in just a few hours, never touching the open air or rough seas. Faster hardware flow means factories never wait. It could change how the world builds computers, cars, and even satellites. Europe's tech economy is already growing faster because of the Eurotube, and other countries want their own networks too. One day, entire global supply chains might run underground or underwater. Shipping could be faster, safer, and cleaner, with less pollution and waste. The world's most advanced hardware might travel invisibly, protected by magnetism, cold, and AI. As the network grows, the line between countries will blur, and the world will feel smaller and more connected. Look around, and you won't see the Eurotube. It's hidden, silent, and almost invisible. Yet underneath our feet, it is changing everything. Microchips, once the most fragile and precious cargo in the world, now travel at the speed of thought, safe inside their magnetic cocoons. Factories get what they need in hours, not days. New inventions reach the world faster than ever. The old days of slow, risky shipping are fading away. In their place, a new era is rising, one of super-fast, nearly invisible hardware logistics. The Eurotube is more than a tunnel. It's a promise that the world's most important technology will never be late, never be lost, and always arrive perfect. This is the underground highway, where the future travels at the speed of light.